Please watch this video all the way through before you start the project. Be sure to assemble all the materials and tools that you'll need before you start. Welcome back. This is part 3 of the AXN Cloudsfly Sailplane assembly. In this section we're going to talk about electronics and power. Before we do that, we're going to talk about some of the basics and some considerations that have to do with the physical assembly of the electronics package as opposed to the electrical assembly. So as we start our journey through considerations for the electrical and power system, let's begin with the batteries. And we need to start with the battery because first of all, it has to fit in the fuselage, and second, it's going to influence both the overall weight of the plane in its finished form, and also it's going to affect the center of gravity of the plane, which is going to have an effect on flying characteristics. There's an old saying that you should do what you can where you are with what you have. In this case, I have on hand some batteries that I use for my quadcopters. And I have quite a few of them, and they aren't particularly inexpensive, so I'd like to use them for this sailplane as well. And they turn out to be a little bit of overkill in one respect and underkill in another respect. The milliamp hour rating of the batteries that I have are 1300, and the supplier of the sailplane said to use 1800 to 2200. But I think the 1300 are going to be fine. It just means I'm going to have less flight time when I go out to the field. They're overkill in the sense that they're rated as 35C batteries, and I think anything above a 20C battery will probably work fine for this plane. But the most important characteristic is their 3S batteries, and this plane must have 3S batteries. You can't use anything else. So as a starting point, in order to do what I can where I am with what I have, I'm going to try to make my 1300 batteries work. I'm going to jump ahead now and show you the final assembly of the electronics in the fuselage. Sometimes you get lucky in life, and I kind of hit the jackpot on this one because, as you can see, my 1300 Kaipom LiPo batteries are a perfect friction fit in the space that's available there in the fuselage in front of the compartment that has the servos. So I'm pretty happy with that result because I don't have to do anything in the way of carving away at the fuselage to make the battery fit. Having selected the battery, I went ahead and put the battery in the fuselage, assembled the rest of the pieces of the plane, and put the plane on a scale to assess how much it weighed. It was 1.16 pounds, so I did a simple conversion from pounds to grams, and it turned out that the weight of the plane in grams was 526 grams. So I went back and looked at the specifications, and the specs say that the flying weight of the plane should be 560 to 600 grams. Now that means my plane is a little light of the recommended flying weight. Then I went ahead and put the plane on a fulcrum using a scale here, an engineer's scale. I just placed the plane on this fulcrum and moved it back and forth until it was just about to the point where it was level. And it turned out that the center of gravity was right about the center of the wing. So I went back and took a look at the specification that came with the manual. And in part 1 I told you that we got lucky because the manual showed us the center of gravity. Well, it wasn't quite right because this dimension X is not actually given to us. All we have is some sort of a visual clue that the center of gravity should be somewhat a little bit ahead of the center of the wing. So let's summarize. We've selected the battery, we've found that the battery is a good fit in the space provided. The plane is a little bit tail heavy and a little bit light, and so the last step here is we're going to have to add some weight to the nose of the plane in order to balance it out and get it up to the recommended flying weight. Well, it turns out that roof tape that we used on the undercarriage to protect it is pretty heavy stuff. It's got a thick tar-like backing on it, and so given the fact that there seems to be a fair amount of extra space in the canopy, what I expect to do is to cut out some pieces of that tape and glue them together. Actually, the backing on them is sticky, so I just stick them together, and then I'm going to take a piece of Velcro and put it in the canopy itself and attach that roofing tape in the canopy so that it can be removed if I need to, but it will provide the extra weight in the canopy up toward the nose to balance out the plane. So here you can see the addition of the removable ballast in the canopy, bringing the final weight of the plane up to 570 grams. And as it turns out, another check on the center of gravity brings it forward to just about the place we'd like it to be. So I think we're ready to fly now. So now that we've got our power system squared away, it's time to turn our attention to the electronics. You're going to need a radio controller, but I can't tell you which one to use. I can only tell you that this is the one that I use. It's the Spectrum DX6i. Here's an economy version of the same radio. The only advice I'd give you on this subject is buy the best radio your money can buy. I use the Orange brand of receiver. They're economical and they've worked well for me. You can see that there are two antennas on this receiver, which gives it signal diversity for better reliability. Here you can see that the rudder, elevator, and aileron servos have been connected to the appropriate ports, and we've connected the ESC motor controller to the throttle port. The ESC also provides power to the receiver. That last connector that you see there with the loop on the end is the binding strap. That's put in place on the battery ground pins just long enough to mate the receiver to the transmitter. Then it's removed for normal operation. You'll need to consult the instructions for your transmitter and receiver to figure out just how to go about binding them together. When the binding procedure is done, we're ready to go ahead and power up the system to verify that everything is functioning properly. Knowing that the electronics are working properly, now we're ready to install them in the fuselage. Here the receiver and motor controller are in their approximate final locations. The receiver is going to go up in the nose of the plane. You can see that one antenna will extend forward and the other antenna is going to protrude out the air vent on the side of the nose of the aircraft. In order to install the ESC, I carved just a small notch on each side in the bulkhead so that I could press the ESC down into place. Here everything is assembled and ready to go. If you look carefully, you can see the antenna protruding from the air duct at the bottom of the nose of the aircraft. And the last few finishing touches are a rubber band over the canopy to make sure it doesn't come loose, hinge tape at the intersection of the wing and the fuselage, both top and bottom, and finally the installation of the propeller with the O-ring that came with the kit. Well, that's it for part 3. I hope it's been beneficial and you've gained something from this instruction. Come on back for part 4 when we're going to head out to the flying field for flight test and tuning. Bye.